that upper loop, which we're kind of calling an end loop, Matt Walker suggested this, and an N just because it's kind of the shape of an N instead of a U. Basically, it's going to act as kind of like a bell, and it's not in the direct duct path. So once our flue gases turn through this T and then turn through this 90, they're already going this direction of the return duct run. And then any heat that wants to come up into this loop, acting as a bell, is welcome to, but it'll just be what decides to go that way. But it's already been forced straight, so it'll mostly run this direction. We'll get some heat rise into this end loop. And then this T is just access. We didn't really need it, but I want to be able to see what's going on in there, just to see if it's collecting ash, feel flow. So when the system's running or a season later, we can see what's going on in there. Again, that T's not really necessary since it's just a bell. In essence, it's a secondary bell. And it will just help heat the back of the couch. We're not making a standard flat bench to sit on. We're making roughly a couch or a pew, if you will. It'll be 18 inches depth of sitting, and then an 18-inch depth of the second section where the back is. The back height will be 42 inches from the floor. The seating height will be 18 inches from the floor. So then it just, whatever decides to come up will then be forced to come back down. As it cools, it will actually come back down easier and join the rest of the gases that went the main route and then go up out the chimney. So our first clean out is for vacuuming into the barrel. And then you can also get a vacuum hose. You can do a flexible hose. You go down through your ductwork this way. And you want to be able to try and get to all the accesses. Usually through learning curve, you can end up with a lot of ash in these. I've seen it in the past. They should burn clean. They shouldn't have a lot of particulate, but depending on users, lifestyle, things like that, and learning curve, it can take a little while to get used to how to run them that way. So you want these accesses, unless you've built these before and you've lived with them before and you know how to run them clean, you can maybe get rid of some accesses. But you'll always want an access near your manifold slash the bottom of the primary bell being the barrel, where you come up out of your riser, the gases expand, fall down the system, and then right where it gets channeled into a duct, which is what the area that we call the manifold, is kind of when it channels from the bell to the ductwork. So the manifold is kind of a nebulous term. Depending on the system, it's kind of always a little different. So it'd be the area right in front of that reducer. I'm not sure if you can see that hole down there on the left side of the screen, but it's the hole that's on the other side of this. So this is our manifold entry. I've used a reducer because my hole is very close to the back of the box, so there's not a lot of space there. And my hole was only a couple of inches from the bottom of the barrel. So that's basically too much restriction for the 8-inch pipe, for all that gas to flow into the 8-inch pipe without restriction. So you use an increaser or something where you get a bigger opening so your gases can get into that ductwork without being restricted. So that's why we used a 10-inch reducer here. So I've got a 10-inch hole at my manifold. Maybe we can see it this way. Let me grab a light. Okay. All right, so let's see, let me put this in a different orientation. Okay, I've got some good light down there. Okay, so yeah, you can see our hole there, so that the area at that hole between the barrel and the riser. That would be called our manifold area. And we've got plenty of room on the right. We've got plenty of room above. But if that were just an 8-inch hole, that'd only be 2 inches from the bottom of the hole to the floor, which is not enough to not have restriction for an 8-inch system. And if we look down here, it's kind of hard to tell, but there would have only been about 3 inches from the left side of the hole to the box. We'll come around to this side. So it's hard to see from here, but you can kind of make out the hole. Rotate on the right side of the screen. And that hole is roughly 1.5 inches from the box. So it would have been about 2.5 inches if it was just an 8-inch hole to the box. And a lot of times it's just fine to run an 8-inch duct straight into your barrel, straight into your manifold area. But the rough estimates are you should have half the distance of your duct. So if it's an 8-inch duct diameter, then it'd be 4 inches. You should have 4 inches from the bottom of the manifold to the floor. And that's partly for ash collection and partly for airflow to not restrict it. And the rest of it is generally assumed there'll be space all the way around it. But our box, again, has come really close to that hole with how the system's built into the couch and where the duct had to come out to work. So, and you can see that the duct is not shooting straight out perpendicular or parallel with the front of the bench. It's actually angled a bit to the back of the bench. That was to give me more room on the front side of that manifold where the box is. So we're able to kick it sideways a little, rotate it back, and we can make up for all that with, you can see I've got the T makes up a little bit of that bend. Then this first pipe, you'll notice, is at an angle to the front of where the bench is going to be. So I've got roughly about 10 inches here from the front to the bench, and we're at about 5 inches up here. And these are just design changes you do once you get all this material in place. You can start seeing, okay, I was planning on this coming out vertical or perpendicular to the front of the system, or parallel to the front of the bench, I should say. And then it was very apparent, no, I want more space than that for the manifold. So we just rotate it back a little, no problem, make up for it in duct run. And then, so now we're back to, we started talking about this T here, and this T is a bypass to the bench run. So it doesn't shut off the bench run, it doesn't close the manifold area or the duct run going through the bench, and it doesn't have to. A bypass will work as a path of least resistance. So get some light back here. Let's see. So now we're looking at, we've got the T right here, and then on this side of the T, we have a door. So you can see the two brass hinges right there, mounted to a piece of 1/8 angle to give it something supporting it. And that door was made out of the cutout of the front of the barrel where the box slid into the barrel. And then we have an actuating rod right here, mounted to a little bracket that had to be fabricated. And what happens is I can move this rod, and right now it's in a locked shut position, so I lift it. There's a little notch, and then we slide open that bypass, and of course it can't open all the way, it hits the riser, and that's just fine because it's a path of much less resistance. So that door opens, you can see the hole going into the T. In fact, this will give you a good view of how I did all these duct attachments to the barrel. So, okay, there's where the hole is on the barrel, and you can see how you've got tabs. So that's an 8-inch duct T. I cut a 6-inch hole with a hole saw, which I handily have, or you can cut it with, you can drill a hole and cut it with shears. You can cut it with tin snips. All this works with hand tools just fine. And then you end up with a 1-inch lip, which is I cut all those little slots. Those slots, they look like I cut out V's, but all you do is a straight cut with a pair of snips. And then when you bend them out, they make the V. And then I just put screws in 4 or 6 of those so it wouldn't move. And then that gives you a nice attachment to the barrel. So it gives you can see where I put screws in the tabs. If you get really close, you can see where those tabs are bent through, little gaps. And those screws are able to attach that T to the barrel very securely. We did the same thing here with this manifold. This is a piece of duct work that basically is cut to form the curve, the arc of the barrel. And it doesn't have to be perfect. I get it probably closer than I need. And then I do screws from inside out. So when you're, especially since this will be the primary barrel clean out, the reason I do the screws from the inside is you can see this screw sticking up. If that was on the inside, which would be the easy way to attach that, then when you reach your hand in here to clean out, or your vacuum hose, you either get scratched or it grabs your vacuum hose, and that's no fun. So while I got the light out, let's get some light in here. Let's see what's going on in the bottom of this barrel. So what we have here is the riser, which is about 12 inches in diameter, wrapped with the sheet metal. You can see the hose clamps that are holding it to the box. And you can see here on the duct where I've bent all those tabs out. Again, I drilled a 6-inch hole with a hole saw and then make a bunch of slices with the snips, just some sheet metal duct snips, or not duct snips, but just sheet metal snips. Bend those out, drive some screws in them, and you've got a really solid connection. So we have the whole system is 1 second while I get my camera back up. All right, pause.